So I've got a sequence here, and I want to know if this converges, and if it does, what it converges to. Remember, to determine convergence of a sequence, I need to look at a limit. And I'm going to take the limit of that expression as n goes to infinity and see what happens. And looking at this, I'm sure the first thought that came into your head was, well, it's 3/4. And okay, spoiler alert, yes, at the end it is going to be 3/4. However, this is a mathematics thing. You got to be careful. Just because we could do something with functions, right? If there were 3x cubed plus 1 over 4x cubed, yeah, we'd be home free. But just because you can do something with one thing doesn't mean you can do it with another thing, no matter how much alike they happen to look. Now, we've already seen that, yes, there are some tight connections between limits of sequences and limits of functions. We're actually going to explore that even more in the next lecture. But we can do this strictly using the limit properties we've talked about so far. So the first thing I'm going to do is I'm going to take that expression that I'm taking the limit of, and I'm going to split it up into two parts. Anytime you've got a rational expression and the denominator is a monomial, that's your lucky day, right? Because I can split it up into two fractions. 3n cubed over 4n cubed plus 1 over 4n cubed. All right, so now I can simplify the first one. I can cancel those n cubes, and that makes that first part of the expression just 3/4, and the 1 over 4n cubed stays the same. Okay, now here's where I'm going to apply my first limit property. I'm going to take the limit of the sum, and I'm going to split it up into the sum of the limits. Okay, now the limit of a constant is just a constant. So that first limit is just going to be 3/4. And for the second limit, I'm going to take that 1/4, that constant multiple, I'm going to bring it outside, and I'm going to slip the limit inside the exponent, inside the third power. Right? Again, two more of our limit properties. And at this point, we're really home free. Right? This limit here, we know what it is. That's just going to be 0. So this is 3/4 plus 0, which is, yes, 3/4. So yes, to answer the question, yes, this sequence does converge, and it converges to 3/4, exactly like we expected it to. If you'd like to get the full context, you can click on the upper link here to see the lecture I was referring to. And if you'd like to see another example, the link below will take you to an example where we look at what happens when you've got the sum of two divergent sequences. Finally, if you like this example or found it helpful, please don't forget to click on the like button below.